Okay, hello, 1, 2, 3, 4, 5, 6. Can you hear me now? Can anyone hear me? What is going on tonight? Can you hear me? Hello, 1, 2, 3. Hello, 1, 2, 3. Okay, great, great, great. Everybody can hear me now. Thank you very much. Thank you so much. All right, so let me share my screen. Let me share my screen. Let me off the camera. VS Code may ask you to connect to the kernel, or if you're using Anaconda Jupyter Lab notebook, then you need to also connect to the kernel as well. And you're using Google Colab, the same thing. You will need to connect to the kernel. Before I even start today's class, you could see that I changed my theme to what do you call it, to the light theme. So let me quickly show you how to do that. And it's very simple. So what we do is to click on View, click on Command Palette. From there you will see Color Theme, Preferences, Color Theme, and from there you can choose any theme you like. So for example, I'm currently on light modern, default light modern, as you can see. So I'm currently on light modern theme, right? And that is how I change my theme. Now let's continue. in creating the ones array. For example, if I just say np.ones and I put 10 here, it will automatically create an array of 10 elements in which all the elements are 1, as you can see. And that is what we have here. Of course, we also have another one which helps us to create an identity matrix. Of course, I will show you how to actually create a matrix, by using array. But for now, let's see how to create an identity matrix. You can create an identity matrix by using np.i's function, np.i oju. Then you put the number of diagonal you want to create. You put it here. So for example, when I say np.i and I run it, you can see I have an identity matrix. Why is it called an identity matrix? If you look at the diagonal, right? Diagonal are for example, this one here, second here, third here is called diagonal. In case you have not done any linear algebra before. So this is a 3 by 3 matrix, and it is called diagonal matrix. Reason being that you can see that all the diagonal elements here, they are all one. That is why we call it identity matrix. All right. So let me create one for 2 by 2 matrix. You just say np.i, all right, and then you insert the number of the what do you call it, the dimension of that matrix. You put it there. For example, here this one is a 2 by 2 identity matrix, and that is how to actually use both np.i and np.ones to create a given array of your choice. I hope you get it. Do you have any question? Okay. Somebody is saying that they miss opening remark as we start again. I don't like repeating myself, please. Uh, you know, Yesterday we talked about NumPy, right? And you saw several ways at which you can create a NumPy array. For example, you can create a NumPy array from a list. And we also, you saw how the difference between the NumPy array and the list. For example, you cannot do arithmetic operation with a list, but you can do several arithmetic operation with NumPy array. All right. And I also showed you how to change your theme. Theme is just, you know what theme should read? THEME, theme, right? And you can do that by clicking on view, and then you select command palette, and from there you see preferences, color theme. You click on it, and then you now choose the theme of your choice. So currently I am on light modern theme, and if you like, you can change it to any theme of your choice. This is another one. I know most of you will be complaining now, so that is why I had to use the light modern theme. Okay, I hope it's clear now. If my screen is blurred, right, remember what you will do is to go to your YouTube and then click on setting, and then you will see. Let me show you. Click on setting on your YouTube like this, right? If you are actually on the LMS, no problem. So click on the settings here, and then select the quality. You can choose 720 resolution, right? Me, because I'm using two systems and I'm not listening to myself, that is why I have to make my own theme to be 144 so as to save my data. And this is not actually controlling yours. What is controlling yours is where I am, which is the StreamYard. But you may be on your LMS, so I hope you understand it now. Okay, yeah. So please, if you are on 144p, change it to 720. Okay, I believe you have gotten that now. So today we'll be looking at how to create a multi-dimensional array. Yesterday we talked about all of this and talked about this, so I'm not going to repeat it again. So today we'll be looking at multi-dimensional array. So the ones we saw yesterday, were just one-dimensional array. Now today we'll be looking at multi-dimensional array. Okay, for example, we look at two-dimensional array, which is the matrix, right? And you have seen a matrix before. A matrix is like this, and this is 3 by 3 matrix. Why? Because we have 3 rows here. 1, 2, 3 is the first row, 4, 5, 6 is the second row, 7, 8, 9 is the third row, and the first column is this one, 1, 4, 7. The second column is 2, 5, 8, and the third column is 3, 6, 9. And in this, if you look at the order, we have 3 rows and we have 3 columns. In that case, we now have what is called 3 by 3 matrix. That is in the order of 3 rows and 3 columns. Okay. Now that we have the understanding of a matrix, and we have said a matrix is a two-dimensional array. Sometimes they call it 2D array. So the D there is dimension. So because it is why is it 2 dimension? We have row and column, row and column. It's not 3D, it's just 2D that you can easily see in the order of row and column. So how can we use NumPy to create or to represent this matrix? And it's actually very simple. So what you do is to use list of lists. For example, you say np.array, right? And the first list here will be of the first row. The second list will be of the second row. And the third list will be of the third row. And then you end your list, which is the list of lists, and you close it. And that will give you this array. As you can see, is this an array? And if you ask for the type, it will tell you is an n dimension array. Okay, I believe you understand it now. So let's do another example to make it better. Now here, who can tell me the dimension of this matrix? Who can tell me the dimension of this matrix? Anybody? Is my file different from the file shared in the zip? It's not that different because this is one is like a teacher note. Just like when you are presenting, you have your presenter note, and people viewing you or seeing you will not see your presenter note, but they will be seeing what you are displaying your PowerPoint. The same thing is happening, for me. It is just like a teacher note, so as to help me because of the time. Otherwise, it will take a lot of time, and we have 2 days for the NumPy. Okay, yeah, this is somebody is saying 3 by 2. It's not 3 by 2. It's not 3 by 2. It is not. It is not 2 by 2. Understand the order. The order is how many rows do we have here? We have 2 rows and 3 columns, so it is 2 by 3. Yeah, I can see Osita, the Momo. You got it. 2 by 3. Who else again? Uh, oh, Enoch, Amau Enoch. Thank you. You got it. Yeah. Ben Becker, thank you. 2 by 3. 2 by 3. Thank you so much. And how do we create this array? Right? Remember, it is you use np.array and then you create a list. So here is the list. Remember, the first one will be the list, and that will be the first row in that order. That is 5, 6, 7. And then after that, you put comma there and you create another list. Then you now end the last list. Then you close your bracket and then you get it printed. So that is just it. Let me give you another example that you are going to do by yourself. Then you now tell me the dimension, and then you will tell me, you will show me how to create it. Okay. so that I'm not just looking at my screen. Let me call it C, and then call it 4. I call it 2. Then I change this one to 7. Don't worry about what you are saying. It's just like it's LaTeX, so it's not Python. So don't worry about that one. In case you are wondering what is happening here. Okay. So now let me make it. Let me destroy this one. Okay. Now, so who can tell me the order of this matrix? Tell me the order of this matrix and tell me how to create it. Once I see 3 people, I will continue. So you have 3 minutes to do that. Thank you. Okay. What is the order of this matrix? Okay. Sunday Baku 3 by 2. Temitope Samuel. Okay. Okay, great. You were able to create it, but you don't tell me the dimension of the matrix. Okay, thank you so much. I think everyone got it. Thank you. So, excuse me. So let's do it together. So I create a code cell, and I call this one C. I call it np dot array, right? So I have a copilot which is helping me to complete my code. You can see that my copilot is wonderful. So I can see it helps me to automatically complete my code, right? I'm using premium copilot. So now if I run this guy now, you can see that I was able to create it, and if I call C, you see that now I have my matrix. Okay, thank you very much. So now let's see the attributes and method of a NumPy array. And we'll be looking at the n dim, that is the number of dimensions. Remember, you all know the dimension of a matrix, that is R by C, the row and by column. So we look at the dot shape method, which gives us the dimension of that matrix or array, and then we look at dot size, which gives us the number of elements in that array. Then we look at dot d type, which gives us the data type of the element in that array. So, for example, I'm going to create a random number, that follow about 50 random number that follow normal distribution. Remember, yesterday we looked at it. So here I'm using the random seed of 1 to 3. So if you follow me, you will get the same result. So the location is the main, and our mean is 60, and the scale, which is the standard deviation, is 10, right? And we are simulating for 50 data. Now you can see I have the raw score. So if I print it out now, I have all of this, which is actually number distribution. So today I'm not going to bother you with more of statistics. So I'm just going to how I call it. I just want to face my business today. So if you look at raw.ending, remember I said ending helps us to get the number of dimension in that matrix. So if I look at it now, look at it. If I press ending and I run it, you will see that it returns one. What does one mean? It means that we have just what do you call it now? It's one dimension array. That it's not two dimension, it's not three dimension, it's not four dimension, it's just one dimension. It's a vector. If you can use that word, vector is one dimension. Okay. And if I look at the shape, right? You see it's returning a tuple, right? And you see 50 comma nothing. So the 50 here is the number of the elements in that array, and because it's one dimension, that is why it returns 50 comma and nothing. Okay. And when you look at the size, the attribute size, right, it just returns 50 to give us the number of, which gives us the number of elements. Okay. And when you look at the dot d type, right, dot d type, you can see that it returns float 64, right? As you can see, why it is float? Because we have decimal places in the array. That is why it returns a float. Okay. So that's just that. um let's go to another example. So here we'll be looking at the two-dimension array, and we have this as matrix, and of course it's 3 by 3 matrix. So I just create it by using by saving the result into student underscore scores as my variable, and I create this array. So now I can start playing with the attributes and methods uh, of that array. For example, I can say student underscore scores dot ending. Remember, the ending will give us the dimension. It's one dimension, it's two dimension, it's three dimension, and so on. Here it is two dimension. What does two dimension mean? It means we have it is in form of row and column, not the number of rows, not the number of columns. Rather, it is the we have row and we have column. That is what this guy mean. Now, if I say dot shape, right, and I run, you can see it returns a tuple, and it is 3 by 3. So this one means we have three rows and we have three columns. Why this one, which is two, uh, is showing that we have row and we have column, row and column. So if we have three dimension, it will be three. In this case, this will be three, right? So that is just that. And if I say dot size, remember the dot size is counting all the elements in that matrix. And as you can see here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. The total element in this array is 9. That is why we have this 9. Okay, and when you call on the dot d type attribute on it, it will return int 32, meaning that all the elements in it are integer. Okay, that is why this guy returns int 32. So any question from here? Any question? If it's clear, say yes. Don't worry if you have never done any linear algebra or math or matrix in school before, matrices in school. So don't worry, it's just to how will I call it, to it's just like an introduction. Okay, we are not moving to the main linear algebra here. Okay, it's clear. Thank you very much. So this will now bring us into the reshape function, right? For example, we can come from two dimension and go to one dimension, and we can come from three dimension and move into two dimension. So please, I'm coming. Okay. So, and that is exactly what the reshape is doing. It helps us to change the shape of that array. Remember, you know what shape means? You know, the number of rows and the number of columns. So you can change it from one shape to the other. And now let's play with this. So for example, we have this, which is one dimension array. As you can see, we have 65, 70, 80, 75, 85, and 90. So if I run it now and I call on does shape attribute on it, you see that it gives me 6 by 1, meaning that I have it's one dimension with 6 elements. Okay, so if I want to reshape this array so as to have 2 rows and 3 columns, so what I will do is to apply the dot reshape method on it, right? And then the order that I want to specify it is the order that I want rather is what I will specify here. So here I want 2 rows and 3 columns. So if I run it now, you can see it returns this. And when I let me create another cell, if I say what is b dot shape, for example, b dot shape, you can see that it returns 2 by 3, right? And if I ask it now that what is the dimension now? Dot uh b dot n dimension. It will return 2, as you can see. But initially, under this array A, if I say a dot n dim, right, it returns 1 because here initially it is a one dimensional array, right? And then when I apply dot reshape on it, I have changed its shape from 6 comma, right, to 2 by 3 by specifying 2 and 3 here, and that is what gives me this. And that is how to reshape, you know, from one dimension to another dimension. When you are applying reshape attributes into a particular array, you must get your mathematics correctly. Otherwise, it will return an error. What does it mean? So any shape that you are putting here, right, when you multiply it, it must equal to the number of elements of such an array. So what do I mean? For example, I call on np.arange here. As you know, this one will give me from what? From 0 to 11, right? And when you count the elements, so it will be 12. So that means that my shape here must equal to 12. Otherwise, it will return an error. For example, if I run this one, now you can see it is 12. And I can also change it. Let's say 3, let's say 4, and 3 here. So 4 times 3 is 12. I will still get a good array, right? And if I like, I can call it 6 by 2. You can see it's still 12. So it's just changing the shape for me, right? But immediately I now put a wrong shape on it, automatically it will throw an error. Now look at it now, np.arange12, and I apply dot reshape on it. You see that 5 and 3, so that will give us 15 because 5 times 3 is 15. 5 times 3 is 15, and 15 is not equal to the number of elements. That is why this guy is throwing a value error, telling us that it cannot reshape any array of size 12 into the shape of 5 comma 3. Okay, so that means that if the number does not match the shape, then NumPy will throw an error. I hope you get it. Any question? Is my audio still breaking? My audio is not breaking. Everything is correct here. I can hear myself here. Okay, so I can hear myself. Okay, Abigail is saying I should use my black team. If I use my black team, hope others will not complain. Let me try to use my black theme. I also prefer black theme. Okay, this is my black theme. Is that okay for you? Can everybody see it now? Okay, Quinty is saying I should use my white theme. So I don't know how to choose now. Please, you okay, Blessed is asking what does the 32 in 32 mean? It's just the, how will I call it, the memory usage, right, of that integer. For example, it could be in 16, it could be in 32. So the kind of the memory. So we need to move into computer science if we are asking this. But it's just like, let me ask Google self so I have to know ChatGPT. Uh, what does what does int 32 mean? Okay, in Python. Okay, yeah, it's saying that it is a 30 in 32 means it is 32-bit integer data type, right? It is not default integer type in standard Python. Regular Python integer have arbitrary precision. However, int32 appears when working with libraries like NumPy or Pandas that uses fixed size numeric data type for efficiency. As I said before, int32 uses 32 bits of memory, which is exactly what I said before. So it is just how the computer store the number, right, in the range of minus uh, minus 2 billion to 2 billion, right? It is faster and more memory efficient than Python default integer for large array. So that is just what int32 means. It is just how the computer store the number in its memory. Okay, any question? Okay, but 34 is saying that white team is better. Okay, please, I'm not going to change this team again after I change it to white. Okay, thank you very much. That's all about the numpy.reshape attribute. Any question? Okay, I believe there is no more question. So today we will be looking at the numpy operation, right? We'll be looking at the numpy operation. This is, remember I said that NumPy array helps us to be able to carry on further analysis, further mathematical operation on array. And we'll be looking at several operations, like scalar operation. We'll be looking at element-wise operation. We'll be looking at statistics, operation such as descriptive statistics. We'll be looking at Boolean indexing and filtering. Then we'll be looking at which one again? Reshaping array for tabular data, which is exactly what we have done before. And then we'll see how we can apply universal array function, in such an array. So it's very simple, and we are going to be fast on this because we still have another mode, which is how to index and slicing an array. Okay, so here, because this is a new script, I'm starting by importing my NumPy module. Okay, so I'm going to run it. It's asking me to select my kernel, and it's connecting. Okay, great. So we can apply a scalar operation. What is scalar operation? A scalar operation is such that you can add or multiply an array by a given number. So that given number is called scalar. or by a given constant, right? When you hear scalar in mathematics or statistics, it means it's a constant that you are multiplying with a constant or a given number. So, for example, I can say what is a plus 2, as can see. So here now is adding 2 to every element in this array. For example, I can say a minus 3, which is subtracting 3 from every element in such an array. And I can say a times 2, and it's multiplying every element in this array by 2. And that is all about a scalar operation. Okay, and let's see element wise operation where we are adding and subtracting two arrays together. Of course, you can add or subtract, you know, from you can how do I call it? You can add any array right together. So for example, I have these two examples. I have an array A which have 20, 10, 20, 30, 40, and 50, and I have an array B which have 1, 2, 3, 4, right? I'm trying to add them together. You can see this one added them together, and we have the result as an array which is 11, 22, 33, 44, and 55. The same way I can also do element wise operation with it. So here I'm subtracting array B from array A. You can see it works. The same thing also applies with multiplication and division, and here we have element wise power operation. What this one is doing is that for every element of array B, right, we are squaring it by every element of array A. And when you run it, it gives you this. So remember, we have I believe you understand what this one means. I'm not talking to a baby here. Okay. So now let's do some quick statistics with NumPy array. And this will help us to prepare for Pandas when we get to Pandas tomorrow by the grace of God. Python is actually useful for data analysis, but remember that Pandas was built on a NumPy array. So if you don't master NumPy, you will not be able to do very well when we get to Pandas for data analysis. So please, that is why it's good to understand NumPy now. Now look at this array, right? We have the scores, and we generated it from NumPy array, and we have this score, right? 55, 68, 90, 64, and 70, right? You can actually how will I call it? Compute for the mean of this course, and it's actually very simple. We'll be using all these methods, right? Which is mean. For example, if you are doing descriptive statistics, we will expect you to have something like n, which is the uh, number of uh, number of elements in the array. We expect you to have average, which is what the main is doing. So if I run it now, you will see that the mean of this score is 75.3, and we also expect you to have something like minimum or maximum, right? So let me do this. If I cut this and I do this, so you see that the minimum is, you can see the minimum is 55 and the maximum is 92. This is actually true. Here is 92 and there's no other 92 here again, and the minimum is 75.3, which is, sorry, the minimum is 55, which is this one here. So if you look at this one, you will see that for every method there, we are closing and we are opening and ending it with a bracket, right? Which is different from the one that we saw before, right? So when you are doing this, make sure you apply this parenthesis, to that function. Okay, you can see that is the minimum, that is the maximum. For standard deviation is .std, right? You can see this is standard deviation, And if you want to get the total score in that array, you just say dot sum, and that will automatically create the total, actually add all the elements together. Okay. And when we get into pandas, this is how we'll be doing it. Can you see? This is how we'll be doing it. So this is the data frame, the variable you want to get the average, and you see dot mean, and that gives you the mean score, for that variable. The same thing here, the standard deviation, you just see dot std, and that is how to do that when we get to pandas. You can see that when you master NumPy, you'll be able to do well, when we get into pandas. Any question? Can we do scalar operation by index? Yes, of course. Yes, of course. But this one that you put here, Mike Cheesy, you will get an error. Instead, you can just say A and say 2, and you add it by 3. This is the correct syntax. So don't worry, we will do that very soon. That is the next script as I'm going to open. Is there any question? I can't hear. Who else cannot hear? Okay, thank you. It's with network. All right. So that's all about this statistical operation with NumPy array, right? So is there any kind of statistical operation that you would like to do that you have not done yet? Since NumPy is for numbers, is Pandas the same thing? So why NumPy is purely for numerical computing? Pandas can do much more. Pandas can work with both a number and text. Remember, when you have a data, the data is not will not be full of number. You have some qualitative data in it. We have two type of data. We have qualitative and we have quantitative. Quantitative are those data that is full of number, and qualitative are those data that is full of text. For example, gender. For example, class of degree, first class, second class, and so on. Yeah. Instead of numbers, can we represent other data like name, class, ADM, etc.? When we get to pandas, you will do much more. You will do anything you like. You will be able to do anything you like. So what about the mode, median? Right. Yes, yes, yes. You can do that. You can do that. You can do that. So to be able to get a mode, right? Because NumPy, right? There's no mode method in NumPy. So what you will do is to it's actually very hard, right? So what we do is to import SciPy, right? For example, you will say import SciPy. From SciPy, import start. So you need to import the start module. For example, from SciPy, import start. Okay. So after that, then you will now use the start.mode function to be able to get your mode. Okay. So in this case, you will do it like this. Let me show you how to do that. Since our data is score, we just say score like this. Score. Okay. So this is how you will do it. You say start.mode and you put your scores, the score array, you put it here like this, and you run it. Okay. Then the next thing is just to say mode value, for example, mode value, right? And then you use the index 0 on it. Okay, and this will give you 55. So that means that 55 is your mode. As you can see, 55 is your, that is the first mode, because there is no mode here, because no number is repeated. You can see every number is unique. So why do we even put 0 here? So let's just say this. You can see it returns 55. Okay, that is the first number. So let's do like this. Let's add 80 here. Okay, and let's add another 80 here. Okay, so let's run it. If you run it, okay, and you come back here again and run this one, you can see it says that the mode is 80, and to be able to extract the mode out, you need to use the index 0, and that will give you 80. Okay, so that's how to create a mode. What if it is 2 by 3 matrix and you want to sum of only the first column or the row? Yeah, don't worry, we'll get there. We'll be able to do that. You'll be able to do that very soon. Okay, so I think we have all understood how to use some statistical functions with NumPy. So let's see the fourth example where we'll be doing Boolean indexing and filtering. Okay, so why are we filtering? Sometimes when you are given a piece of data set, so you may want to carry out some operation. For example, now in your parish, for example, you want to filter, you want to know those people that always come early for digging deep, for example, right? Let's say the admin, they've collected data and they gave it to you, and from there you want to filter. Maybe they want to give them an award, and how can you filter those people that only come early for the digging deep? That's exactly what filtering is all about. For example, look at this one. You have a score, right? A score of, which is an array, right? Let me run it. You have this, and then look at this. Here we are checking for each element in this array if the score, right, is greater than or equal to 70. Where it is greater than equal to 70, it will return true. Otherwise, it will return false. As you know that 55 is not greater than or equal to 70. That is why this one return false, this one return false, and this one, because it is 80 and is greater than 70, it returns true. Now, to now apply filter, right, what we do is to call on the name of the variable, which is an array. You can see scores, and you now use a square bracket. Then the condition that you have here, you put it inside that square bracket. And when you run it, what will come out, the result will now be the score that is less than, that is greater than or equal to 70. So if I run this one now, you can see I only have array, that is greater than or equal to 70, as you can see. So this is how to filter for a given array. Okay. I want somebody to show me how to filter for a score that is exactly 85. So who can tell me how to filter for score that's exactly equal to, sorry, that's exactly 85? I'm waiting. I'm waiting for you, please. It's up to you. It's okay. Vic W7, you try, but this will return an error. Please try to correct yourself. Thank you. All right, thank you so much. Fable frames, you got it. Axis Alako, you got it. Thank you. All right, all right, all right. You all got it. Thank you very much. So the question is, we need to filter for score that is exactly 85. And to do that, you just type the name of the array, right? And you use a square bracket, and then you call the scores again, right? And you use double equality sign, and you apply 85 on it, and that will give you, as you can see, it's only 85. Which one again? Let's see. That is exactly uh which one again? Okay. Let me create another data. Let's say gender. Okay, I'm coming. Yeah. I'm trying to write into my notepad. Then you will see everything very soon. Okay. So let's create an array of gender, right? Let's create an array of gender. Okay, here we just have this, okay, and we run it. So for example, I want anyone to filter for male for men. How will you do it? If you have this an array, how will you do it, please? Anybody? So who can tell me how to filter for male for female here? Oh, that means Lola, you did not get it. This will return an error. You nearly got it, but you don't get it very well. Sorry. Try again. Anybody? Anybody, please? Okay, thank you so much. Ayola, you got it. Blessed Alade, you did not get it. Data evangelist, you did not get it. Fortune, you got it. Fables frame, you did not get it. Sorry. Adedeji, you did not get it. Olive, you got it. Okay. So let's try it. I will show you why most of you are not getting it. So here you just say gender, right? And then you say gender, then because we want to filter for female, so what we do is to use double equality sign, which most of you got. And then since you want to do for female, this is it, female. Most of you are not using the quotation. That is why you did not get it. So if I run it now, you can see it only shows me the female data, right? You can see this one is data type use 6. Okay. Reshape, we have already done reshape already. So now let's move on to other U functions, which we call universal array functions. And this one is actually very simple. You can call it more of mathematical operations, just like we have statistical operations such as dot max, dot mean, mean, dot median, dot standard deviation, and so on. The same thing is happening here. Instead of saying you know, instead of saying dot sqrt, under the A, we just apply it as a function, not as a method. So there are times that the dot method will not work. Instead, you have to call the function by yourself. For example, most of these universal array functions, are not method, they are functions. So that means that we get them from NumPy, not the array itself. Remember this one here, look at it, this one dot reshape, right? It's a method. Dot shape is a method. Dot engine is a method. Dot which one again? Dot d type is a method. But here under this universal array is not a method. You will call it from the NumPy module. Remember you have said import NumPy as np. So this time around, when you want to use square root, you just say np dot square root, and that will give you the square root of each element in this array. And if you want to get the exponential, maybe you want to do exponential transformation, so here you just say np dot exp for exponential, right? And that will give you the exponentiation of each element. And if you want to do logarithmic transformation, this time around you say np.log, and then you put your array there, not a.log. For example, let's try it. Say, since you have been doing a dot something since morning, let's say a.log, for example, which will throw NumPy n-dimensional array. Object has no attribute log. So that is why a.log will not work. The same thing, a.square root will not work. A.square root will not work. So you have to do it as a function. Okay. Of course, sine 30, sine 45, sine 90 in mathematics at that time. If you don't know it, I don't think you will be able to pass your O level. And I believe everybody passed their O level. Glory be to God. So now to get the sign of each of the elements in the array A, you just say np.sign A. Can see that school is not a scam and mathematics is not a scam. You can never dodge mathematics. You will still see it wherever you are, anywhere. Okay. And now let's play with the last example. Here we'll be doing data transformation. Okay, we'll be doing data transformation. For example, we'll be working with a daily sales data, right? And we have this as an array, that is 12,000, 55,000, 75,000. Here we want to convert it to thousands of naira, and it's very very simple. What we do is to divide the array by 1,000. Okay, so when you divide it by 1,000, you'll be able to get this one. And for example, imagine this is your sales in dollars, right? And you want to now excuse me, this is your sales in naira, and you want to now convert it to dollar. How will you do? What will you do rather? What you will do is to know the exchange rate. For example, as of today, I think let me ask Google. For example, let's just make it 1,500. So now let's say $1 is 1,500. So when you run it, you will get this, and this is okay. There's another under this u function, right? We have this function called dot clip. And what does it do? So this dot clip help us to be able to balance our range. For example, imagine I give you an exercise, for example, because all of you are so brilliant, and maybe I gave you a bonus question that if you are able to solve that bonus question, then you may score more than the total score. I've seen people scoring 110 out of 100, which means that they are extra, brilliant. So maybe I now want to clip it. I want to now, balance the score so that it will not be abnormal again. That is what dot clip function is doing. So here it will help you cap your extreme value. For example, it has the following parameters: the a underscore min, which is the minimum, and the a underscore max, which is the maximum, so that the number will not go above this range. Okay, when I apply this, okay, you will see that I now have this result, which somehow looks like the original array. But if you look at it, we have extreme values such as 15,000, and here it has uh it has kept it into one into which one 100,000, right? So any value above this or below the minimum will be carved into this range, and that is what dot clip function is doing. I believe you understand it now. Okay, now let's see the last one. Here we are doing logarithmic transformation of sales. So for example, when data is not normally distributed, and you have an assumption that your data must be normally distributed. So how can we make that data to work? At least you cannot throw the data. Imagine you spent a lot of millions of naira to collect data, and the statistician is telling you, I'm sorry, ma, we can't do analysis for your data because your data does not follow a normal distribution, right? You can't throw away data. So that is why we have several transformation which we can subject your data into to make it work. In statistics, you can make anything to work. Okay. So now, how do we make this data to work? We can actually use logarithmic function to transform the data. You know, for example, this is how to do it. You just say np.log and you put your array into it. So we are adding +1 here because when you say log zero is to infinity. It will not return any valuable number. For example, let me try it for you. Let me just say np.log and I put 0 there. You can see it will return uh, infinity. Can you see I minus in, that is into negative infinity. So that is why whenever you are applying logarithmic, transformation into your data, always add a particular scalar number to it. Could be 1, it could be 0 point something. So if I just say plus 0.2, for example, now you can see I will be able to get my result. So that is why we are adding 1 here, and when you run it, you have been able to transform your data into this. Okay, and maybe you want to now you want to transform this data back to the logarithmic function. In that case, you can use the exponential function to do that. That is np.exp and apply to the result. Then you now get your logarithmic function. I believe you all get it now. Any question? Tech Plus is saying that he's so tired and almost confused. Sorry, don't be confused. Remember, your name is Karen Tech. You are a tech person, so don't be confused. This is just mathematics and statistics that you need to master. But don't worry, I'm writing a book for you. Once you are able to read it, all this will not be hard. Sorry. Okay, any question? Okay, you don't get the log. Okay, let's create the log. Let's create log, for example. Let's say that let's say uh we have sales data, for example, sales data. Okay, and here we are creating a NumPy array, right? So, and this is it. Just like the last one. Let me, okay. uh Copilot suggest for me now. Copilot is not suggesting again now. let's say 30,000. Okay. So this is this. Okay. So imagine you are working, you know, on your dissertation, maybe for your PhD or your for MSc or for anything, right? And you were told that you should transform your data. You should apply logarithmic transformation into your data. And how can you do it? That's exactly what we are doing here. So we are saying that to be able to apply logarithmic transformation, what we do is to say np dot log. Okay, this is it. And now you now apply your array into it. Okay, you apply your array, that is sys. Okay, your sys data, you apply it there and you run it, and that gives you the result. Okay, but imagine, right? Let's say a particular month or day comes and you did not sell anything. It's possible. Room every time cannot. Of course, you are praying for a good day, but sometimes one can be tired, just like somebody is tired here. Okay, so let's say that there was no sale here, there was no sales here. So now, if we apply logarithmic transformation in your data, you can see it's returning an infinite, right? So because you cannot calculate the log zero. So that is why we always add a constant or scalar number into it. So for example, you can just say plus one, which is not actually that is negligible, right? So when you run it now, you get your logarithmic transformation. That's exactly what I'm saying. Any question? Any question? Hello, any question? I'm using a teacher script. Just like your lecturer will not give you what is reading for you. I'm just using this one here. But what I have here is almost closer to what you have in your own script. Don't worry about if you don't have this script. Okay. Any question? All is clear. None for now. Thank you. So don't worry. Sometimes when I'm learning something, I will be like, oh my god, where in this life will I apply this? Where in this life? Sometimes you will have a case scenario whereby you will be able to apply it, and in the next 2 or 3 years, you may not even apply it. But one day is coming whereby you will have a case scenario to apply it. For example, um, which one? Oh, uh, okay. I study statistics and I do several courses in sample survey. And for many years after I've graduated from the university, I've never applied my survey methodology in any project. But to God be the glory. Uh, five, five, uh, 5 months ago, right? I was in a particular project, and it is necessary for me to understand sample survey. So now I now remembered everything that my professor taught me at that time, and I was able to apply it. So that's exactly what can also happen to some of you here. Maybe your next project, you will need to do transformation, then you just apply either logarithmic transformation or apply exponential transformation or any transformation of your choice. So that's just it. So now let us have a break. I'm going to give you a 3 minute break. So you can stand up, you can drink water, you can go and eat yourself, and you can stand up, sit down, stretch your body. Aha. How I wish we can see ourselves so that I show you how I always do my own exercise when I'm teaching for long hours. Can we go for a 10 minutes break? We can't go for a 10 minute break. Oh. We have 60 minutes in an hour. So if you go for 10 minutes break, then we now have 50 minutes remaining. I remember you are learning, you are becoming data scientist and machine learning engineer within 8 weeks. I remember me, I study statistics. I studied statistics for 4 years, MSc and several projects, all of that. So that is why I'm not going to have a break for 10 minutes. Instead, let's have it for 4 minutes, please. The I method will give you identity matrix, and the same identity matrix you can do it by yourself. Okay. Okay. So any question, please? Okay. In learning better by far. Okay, oh, better by far. All right. Thank you. I should do review. Okay, don't worry. We'll do review when we are done. Because let me see how long it will take me to complete this mode. Because we must complete NumPy today. Today, by fire, by force. I'm not rushing you, but it's a must for us to complete today. So that my other facilitator will not be angry with me. Okay, let me quickly do a little review, for this. Excuse me. So the break is over. How do we export any statistics done to Excel for visualization or dashboard if you are working on a research project? So don't worry, I'm going to cover Pandas tomorrow, and you see the beauty of everything, right? And you'll be so happy that you are attending this training. Okay, don't worry. In Pandas, I'm going to before we even move into Pandas, I will show you some fantastic things you can do with Excel, so that we now use that knowledge, in Panda, because I always like to showcase that everything you can do in Excel is what you can do in Pandas. Pandas is just a library in Python, right? And we are not using Excel because when you have a big data, we are working with a big company like MTN, like Google, like Meta, or which one again? Like GT Bank, that have data of many customers in time of millions of rows. Excel sometimes will be so slow, and you too, as an analyst, you will not be happy with yourself. Imagine you are just doing discrete statistics and it's taking you about 30 minutes before you can do it, because you are having big data. And in fact, when you have more than 5 millions of rows, then Excel will cut off the data. And if you are not careful, you'll be in trouble. They will arrest you, because it can bring failure to the company, because the data you are working on has been cut off and you are not aware. Of course, Excel will alert you saying that some data has been cut off. So that is why we are learning Python, Pandas, to help us with our big data. Just like I told some sort of people, I don't know if it is here. If anybody ever asks you if you have worked with big data before, don't say no. And of course, as a Christian, it's not good to lie. So today, before you sleep, make sure you get data from Cargo and try to duplicate that data so that you have more than 2 million 2 million rows, right? So that you have 2 million rows. Open it, close it. Anywhere they're asking you in the interview, tell them you have worked with big data before. And in that case, you are not lying. It is true that you have worked with big data. At least you have opened it and you close it. Okay. And now let's do a little summary of everything you have been learning so far. So I will even start from that of yesterday, but I'll be so fast with it. Within 3 minutes, I'm done. So yesterday we started with NumPy. So NumPy is a module in Python, right? And it helps us to create n-dimensional array. Okay, and from here we saw several ways at which you can create a one-dimensional array. For example, you can create one-dimensional array from a list. You can create one-dimensional array by using random generator. You can also create one-dimensional array by using some other functions. Okay. Uh, we also covered some distribution yesterday, at which you can simulate data to get an array. For example, we saw how to get data from standard uniform distribution, where we have the data the range must be between 0 and 1. Yesterday, I forgot to inform you that standard uniform distribution is a continuous type of uniform distribution. And we have general uniform distribution, and that one too is also a continuous, uniform distribution. That is, it will be between a particular range. Now we now have a discrete uniform distribution. In this case, its own range, right, can start from a particular number to a particular number, but everything you are getting from it will be number you are getting from it will be in decimal places. For example, you can see here is continuous, and the data here, if you run it by yourself, you see it will be 10 point something, 20 point something, and so on. But under the discrete, they call it discrete because it is, how will I call it? You can count it, right? 0, 1, 2, 3, not 1.2, 1.5, and all of that. Okay. Then we also saw how we can split data from the standard normal distribution. And yesterday we said that standard normal distribution it has a mean of 0, a standard deviation of 1. Okay. And today we look at several operations we can do with NumPy. For example, we can do scalar operations. And what scalar means literally is you are multiplying your array, by a particular number. Okay, when you hear scalar, just remember constant. Where in mathematics you say where k is constant, and at the end of the day, when you calculate that k, you can see that that k is a number. So that is exactly what scalar is doing here. For example, I'm adding array A by 2. Subtracting array A. I'm subtracting 3 from array A and all of that. For example, in the element wise operation, what we are doing there is that you can add, subtract, several array, from each other. That's exactly what we have here. Okay. And where each one again. Then we now move on into applying statistics to our array. For example, you always hear about descriptive statistics. And what does the statistic does? It just summarizing your data. Okay, for example, here you have the array, you have the score, which is an array, and from there you can get the average. And you know that another word for average is mean. So that is why in Python they always say main. In R programming they will say main. But when you go to Excel, Excel will say average. When you say main, Excel will throw an error for you. Okay. And somebody asked me, how can we get a mode from a particular array? In that case, the mode, right? It's not in NumPy. It's not in NumPy module. That is why we are importing the start module, the start function from the SciPy module. From SciPy import start. I believe you understand what this one means yesterday. And then we now, from this start, we now get the mode. Okay. So here we apply our array here. And when you say mode underscore value with the index 0, it throws this one 80. That is, the mode is 80. Okay. And you can see where we also apply other statistics such as maximum, standard deviation, and so on. And we also look at the Boolean indexing and filtering. Okay, you saw we have the scores array, and then from there we are filtering score that is at least 70. Whenever you hear at least in mathematics or statistics, it means from that number upward. And the notation is greater than or equal to. When you hear at most means from that number downward. That is where you will use less than or equal to. So that is just that. And then we also look at how we can reshape an array. Reshaping an array means you are changing from one shape to the other, and that is exactly what we have done. And then we also apply some universal array functions. And what this one means is that they are not attributes or methods of an array, but they are just function from NumPy module. That is why you will see np.square root, np.exponential, np.sine, np.log, and so on. Okay, and that is exactly what we have been doing for the past 1.5 hours. Any question? Victory is asking, what about having large size of data like 30 to 500 rows of 40 columns? How can we deal with that? This one, by the grace of God, tomorrow you'll be able to answer it by yourself. We will be using Pandas to do all of that. So just get ready tomorrow, okay? And if you want to be ahead of the class, I've already sent you a video that will help you. But based on the statistics, most of you are not watching it, but it's not a problem, okay? But if you want to know ahead of the class, you can easily leverage that. Okay, now let me now move on into the indexing and the selection of an array. Okay, what do you mean by indexing or slicing an array? It's actually very simple. So imagine in your parish, for example, okay, in the order of hierarchy, I may not be correct. You have pastor, you have the pastoral, right? You have the chorister, you have the usher, you have the which one again? Which department again? Anybody? Which department again? Okay. So now let's say you selected one member from each group, okay, and you now order them. Now, if they now ask you who is in the third position, you'll be able to mention their name. Who is in the fifth position, not in terms of performance, but in terms of the how you lay them, right? So you'll be able to answer them. That is exactly what you want to do here. So, for example, I will be starting with the ages array. For example, here are the here are the 6 members of your parish, right? And their ages are in this form: 18, 20, 22, 19, 21, 23. So if they ask you who is in the third position, whose age is in the third position, you'll be able to answer it because of this arrangement. And now that brings us into the understanding that indexing of an array starts with 0. Okay, don't forget it. That is one problem I have with Python. Okay, its index starts with 0 because 0 is part of a natural number. Don't let me take you to pure mathematics. Okay, so here you can see 0. So anytime you are counting, in Python, just bend to the 0 index, 0, 1, 2, not 1, 2, 3, that you know, but just start from 0 and you will not have problem with Python. Okay, so here we have the index, as you can see. For 18 is index 0, 20 is index 1. So if I just say what age is in index 2, you just tell me is 22. What age is in index 4, you just tell me is 21, and that's all. Okay. And we also have reverse index. In this case, you are using negative index. For example, this is -1, -2, and so on. When you apply negative index, for example, -1, it will give you the last number of that array. So if I just say -1, it will give me 23. If I say what is the value of the age in index -4, you tell me is 22, and that's when you understand this, you don't have problem with index. So any question? Is computer binary language? It's not computer binary language. When you say binary language is just series of 0 and 1, and here it's not 0 and 1. Okay, can you have -0? I'm sorry, you don't have -0. Just use your -1, JJ. Okay, so now I import my NumPy as NP, then I connect to my kernel because this is a new script. Okay, right, great. So now if I look at it now, when you are saying index, in this case you will call the array, this is ages, okay, with a square bracket, and you apply the index on it. So when you do like this, then it will give you the value whose index is 0. As you know, the index of 0 is what? The age is what? 18. And that is why we have 18 here. And when I apply ages with index -1, then it gives me 23, which is the last age in this array. I hope you understand. It's very simple. When you say ages square bracket, please don't use this parenthesis. You get an error. Okay, if you want to know Python, you must you must you must be guided by its principle. Okay, not your own principle. It's Python principle. If you want to work with God, you must abide by his rules and regulation according to the Bible, according to the scripture. Okay, so here now ages with the index 2, you will see that it is what? It is 22. So that is just it. Now I want to create this. Let me create uh okay, let's simulate a number. Let's simulate a number. So here we are calling it a score. Okay, and here we are simulating np dot random. We are simulating random dot normal. Okay, a normal distribution. Here we are simulating 10 number. No, let me use 20 number. We are simulating for 20 number, which follows normal distribution with the mean of 75 and the standard deviation of 10. Okay, so that is what we have here. And when you call for this variable, you get all of this. Okay, and no, don't let me use don't let me use normal. Let us use uniform. Okay, uniform. Okay, uh okay, All right. So, sorry, uh, is round int because round int is integer. Round int. Okay, round integer. Okay. So here is it now. So who can tell me if I want to get this 6? How can I do it with NumPy index? How can I do it? Anybody? I want to obtain this value of 6. So how can I do it? Please give me the answer on the chat. Thank you. I want to get these 6 elements here. So how will I get it? You know, my array is scores. So I want to get this value 6. How can I obtain it? Score 6. Exactly. Score 6. Thank you so much. Temitope, thank you. Ebenezer, thank you so much. Okay, okay, thank you. Thank you. What about 9? What about 9? What about 9? The value of 9. How do I do it? Okay. How do I get this 9? Okay. See, I told you endurance. If you are saying score 2, you will get an error. You are using a parenthesis instead of a square bracket. There is difference between a parenthesis and a square bracket. There is difference between the two. Please don't make that mistake, otherwise you get an error. Okay, thank you, Yetunde. You got it. Yetunde Akinmoju, you did not get it. But Temitope Akintoye, you got it. Thank you. Most of you that are not getting it, okay, I'm going to find you with $20 each. Steven, you don't put anything in your index. Somebody asked a very good question, and the question is, how can I automatically get an index of a particular value? And it's actually very simple. Okay. Uh, okay. So let me say I want to get the index of this 9. So how can I automatically get it? Okay. So what you will do is to say um it's to say np dot array no, not np dot where, np dot where. Okay, and then you now put scores, right? They say it's equal to, let's say, 9, for example. Okay, when you run it, you can see the index is 2, and that's exactly what you are all doing here, saying score with a square bracket 2. Okay, so that is how to get the index. All right. So now if you are saying the index of 7, but there are many 7s there. Okay, so here are the uh in this. Okay, can you see 3, 4, 7, 9, 16, 17? So because there are so many, you can see 7 is here, 7 is here, 7 is here, and that is why we have all of this. Okay, so now let's see how to do some slicing. For example, you may want to get 2 values, you know, from a particular array. How can you do it? And we'll be using this example. For example, let's call out our ages array, okay, so that I can see what is happening here. So if I want to get, you know, index 1 to 4, remember here is 1, 2, 3, 4. So to give me 20, 22, 19, 21. Okay, whenever you are using 1 and 4, right? So Python will start with 1, then subtract 1 from this, making 3. So Python will not end with the last number. Instead, it will be n minus 1. So that's why when you run this, you will get 20, 22, and 19. The index 1 is this 20. Okay. Index 2 is this. Index 3 is 19. That is why we have this. Now it's becoming utter now. So this one, when you say ages with colon and 3, what is it doing? This one is just giving you the first 3 elements. Okay, the first 3 elements. You know, the first 3 elements will be 18, 20, and 22. That is why you have this. And when you, let's do another one. Ages. Okay, let's say we need the first 2, for example, just say colon and 2, and that gives you this one. Now we have another one. So here, can you see what is this? Ages bracket 3 colon. So this one will start with 3 and they end with the last number. If I run it now, I will get 19, 21, and 3. So if you recall, your ages vector, okay, is this. When you say 3 colon, will now be from the third index, 0, 1, 2. The third is here, okay. Sorry, 0, 1, 2, 3. The third is here, and then it will not take it to the end. Okay, for example, let's say 4, okay, and that will be 21 and 23. What does it mean? From the, can you see the fourth index? This is 0, 1, 2, 3, 4. So the fourth is starting from 21, and this guy is saying from the fourth to the end. You can see this is the fourth, and the end is 23. That is why you have this. Any question? Yes, from the fourth to the last. Thank you, Temitope. You got it. Yeah, fourth to the end. Thank you so much. We now have another one here. Can you see? Dot dot colon 2. What is that one doing? Is what it does is that it's selecting every second element, just like you have 2, 4, 6, 8, 10, 12, and so on and so forth. That is exactly what this guy is doing. Every second element. If you put 3 here, it will be every third element. For example, you can see here is 0, right? Here is 1, here is 2, here is 3. What are we doing? Sorry. Uh, uh, this is 2, every second element. Yeah. 18, 22, 21. Yeah. So this one is starting from 0, and they start taking every second element. You can see here it's starting from here, 18, then after 18, 1, 2, the third one with 22, the 21, and then since there's nothing again, that is why this guy is like this. Can you see? Okay. All right. Now that you know how to do slicing and index of an array, remember that when you extract such a value, by using index or slicing, you can actually change the value that you index. For example, you say that ages with index 0 is 18. So if you want to modify this 18 to be another value, you can actually do that by saying it's equal to 19. All right. And when you call the number again, when you call the array again, then you will see that it has changed. And before, remember before, it was 18. Here is it, 18. Now we are saying that the first element, which is 18, has been modified into 19. That is why when you run it again, you get this one. Okay, that is how to modify an element through indexing. Here's another example. So here, look at it. We are slicing from 2 to 4. Okay, when you slice from 2 to 4, it will give you something like this. Oh, excuse me, I can put a comment here. It will give you something like this. So that means that it extracted 22 and 19 from the array. Okay, now I'm not saying that those number extracted, right? I want to change them into 21 and 20. Okay, when you run it and call out the ages again, it has changed those number to 21 and 20. Somebody could ask me, but ages is an array, while 21 and 20 is a list. Why are we now putting something that is not of the same data type? Why are we putting them together? For example, what I mean is type, right? You can see this one is a list, right? And ages, what we get from here is an array because it was created from an array. You can see when you just say type or say dot d type, it will throw an array. You can see. So why are we putting them together? Of course, you can actually put them together. Otherwise, you can start make the life complex by saying np by saying np dot array. Okay, and do this. Okay, it will also work. All right, and you call the ages. You can see that it still gives us the same thing, right? So that is just that. Uh we have 10 minutes more. Uh it's actually, we have done all of this very simple. This Boolean, we have done it before in the operation, right? So where we are filtering the data. So we have done this, and I believe you know how to do it. Now somebody was asking, how can we index, from two-dimensional array? Okay, it's actually very simple. So of course, you know how to create two-dimensional array, and you know that here is the row, and here are the columns. Can you see? Here are the rows, here are the columns. So when you are getting data from them, you'll be using it in two dimensions. The last time we were using one-dimensional array. That is why we have a square bracket without any comma. But because two-dimensional array, we must specify the row index and specify the column index. So that is why when we have, let me run this guy. It's a two-dimensional array and with 3 by 3 dimension. So if I just say 0 0 0 0, what does it mean? Here you can see here is row 0, right? And here is column 0. So where they intersect is the value we get. In this case, it is 65. That is why this guy returns 65. Okay, and this one is extracting from the first row and from the second row. Remember, 0 is the first row, 1 is the second row. Don't be confused, because the index of Python can confuse anybody, even me, because because okay, sorry. Here you can see, here is the second row, and 2 is the third column. So when you run it, you will get the result. Okay, and if you want to access entire row or entire column. For example, this one, for example, what does it do? Okay, look at it. Here it's saying that you want to extract, or when there is no number, right? It means you are extracting all the rows. But here you can see you are extracting only the first column. So when you run it, you will get this. Can you see? The same thing here, all the rows, but the third column, and that is that. Okay. Here's another one. Can you see? Here you are extracting all the rows, but only the first and second column. Okay, that is column 1 and column 2. Remember, 1 to 3 means that you are starting from 1 and end at 2. Don't be confused. Okay. Of course, 1 to 3 means 1, 2, 3. But Python is n minus 1. Remember. So that is why this one will start from 1 and end at 2. And that is what gives us this dimension. Okay. Look at this one. This one will start from 0 and end at 1. So you are extracting from the first, you are extracting from the first, from the first row, and so here you are extracting for the first two rows and all column. Remember this here column saying that you are not specific. In this case, it will extract all the columns for you. But here you are specific here. Okay. So this one will just extract the first two rows because here is 0 to 2. Okay. And which one again? You can also modify value just like the way we did for one dimensional array. Okay. And and you can also apply some operations that we did before in the one dimensional array. For example, look at this one. If you want to extract the second column, you remember this is how you will do it. And from there, you can start applying the operation, the dot minimum, dot maximum, and all of that. Okay. Someone that was asking me if I have a particular matrix and I want to, let's say I want to get the total, right, for a particular column. How do I do it? This is exactly how you do it. Okay. This one, remember, is going to give you the sum, across column for each row. When you say axis is equal to 1, so it starts, the axis here, we have axis, it's either 0 will be for row, and 1 will be for column. Don't forget it. When you say axis is equal to 0, that is the operation is towards the row. When axis is equal to 1, it means the operation is towards the column. So that's exactly what we are doing here. Score the sum bracket, axis is equal to 1, then it will give you the sum of all the column in the column for the matrix. Let me extract this so that you can understand what is happening here. Scores, okay, scores. Uh, so this is it, right? So when you now say score, let me copy it and paste it here. Okay, look at what we are doing here. Look at it. Axis is equal to 1. Okay, so who can tell me what this one is doing? Hello, who can tell me what this one is doing? Who can tell me what this one is doing? Hello? Hello? column addition of rows. Okay, so let's do like this. Okay, let us add this together. Okay, so imagine you have this. Okay, and you add this. See what happen. You have 215. So it's adding the rows. Can you see? It's adding the rows. So the same thing. Let's do this one so that you can understand what this is doing. Plus plus. Can you see? 250. Okay, 250. So it's adding the rows. Can you see? It's adding the rows. Now, when we say axis is equal to 0, all right, you can see. Now, this one is summing, each column. So let's do it again. This one will be 65 plus 75 plus 55. Okay, you can see 195, and that is what we have here. So this one is adding the 0 is adding the column, and the axis equal to 1 is adding the rows. So that is how to understand it. Any question? Any question? Can I transpose? Yes, you can transpose. You can transpose. You can transpose. Let me show you how to do transpose. Let's say you have this matrix, right? You have this matrix core. So to transpose this matrix, so transpose means you are changing element from row to column. Okay, and it's actually very simple. You just use the dot transpose method. For example, it will be scores, okay, dot t, capital T, and that will transpose it for you. Can you see? So 65, 70 for the first row become this for the first column. This one, the second row, become the second column, and that's how transpose. It's very simple. Do you have to memorize all the functions? No, no, you don't need to memorize all the functions, but you must familiarize yourself with all the functions. Don't memorize anything, but familiarize yourself with it. That's all. If you don't know, if you familiarize yourself and it's time for you to do a particular project, ChatGPT is there to assist you, okay? Because you know what you ask ChatGPT. Yeah, but you don't need to memorize, don't memorize, but just familiarize yourself with it. For example, if I just say, if I say, at least you have studied mathematics, if I say sine 120, right? You understand that sine is just to get the sine of 120. That's all. Okay? So you don't need to memorize the value of sine 120. Just just type your calculator and get the result. The same thing happens here. Okay, understand what you are doing. Okay, and use ChatGPT for the rescue. Nobody is banning any programmer from using ChatGPT, but what we are banning you, from is to not know what you are doing, but just go to ChatGPT, and copy and paste. No. Okay, I think it is time to call it for another day. I hope today class makes sense. If it doesn't make sense, just try to play the video again. All right. And your assignment will be for you to this one NumPy exercise in the document we gave you. Okay, just find a way to do all of this. Okay, do this, do this, do this, do this, do this, and that's all. Okay, and that's all. So tomorrow, by the grace of God, we'll be looking at how we can use pandas for data analysis. And I will beg you, in the name of God, come with your data. Please come with your own data so that we can play with it. Of course, tomorrow we will not start importing data, but you will see how to create a data frame, right? You will see how to create a data frame. And once you know how to create a data frame, you know how to create a series, you know how to create a data frame, and you are familiar with all this, then we now move on into how you can import your own data, be it any format, CSV, Excel, which one again, Stata, XPSS, even to the extent of scraping data, from the internet. All right. Their assignment is on the document, the zip folder they gave you. Just look for NumPy exercise, and you will get it there. Moses, you have the file. Moses Tosin, you have the file. The file is your. This is it. You all have access to this one. The get analysis folder, the zip folder. Then from there you see NumPy. Okay, open the NumPy. You have this. Can you see NumPy exercise? Okay, NumPy exercise, and that is how to get it. The document I gave is not the same as your own. It is almost similar, right? My own just have something that will guide me so I have to know what I will say when I am teaching you. Okay, it's still the same thing. Where do we submit? I don't know how you always submit before, so just ask your admin. They will show you how to submit it. Thank you. Okay, please, let's take some time to rest. Go and enjoy your evening. The Lord be with you in Jesus' name. How do you import the file into Jupyter? Which file are you talking about? Madam Quick Beat Cakes Aderonke. Which file are you talking about? Transposing the value. Transposing value, for your matrix, just say A dot capital T. I will transpose it for you. So that's just it. Please enjoy your evening. Bye bye.